Okay, so the resource allocation graph will tell us how the resources are allocated for each process. So, uh, in the last part we have seen for processes, so resource 2 is allocated, so the direction, then process 1 is requesting the resource 1, see the direction it is requesting, then resource 1 is allocated for process 2 and so on. So there are two instances of resource 2, one instance of resource 1 and 3 each. Okay, so we'll see with the example how we can uh, identify whether there is a deadlock or not. Okay, so this is the resource allocation graph. Will there be a deadlock? So this is the system model which is given, and we have to check with respect to these four conditions and whether the deadlock has occurred or not. First, we'll see the system and just make out the point, like for process 1, 2 and 3, what are the things they have given. So for process 1, it holds the resource 2, one resource, and it is requesting a resource R1, but it is held by process 2. So I will just draw this diagram where process 1 requesting process 2 for resource resource R1 resource. Okay. Then in the meantime, in process 2 is uh, requesting a resource held by process 3, that is resource 3, hence the direction is given here. Then so resource 1 is allocated for process 2 and resource 2 is allocated for process 2. Okay, so that is what we have uh, just seen with this system model. Then process 3, in the meanwhile, it is actually requesting a resource held by process 2, hence the diagram, hence this. So there is again a cycle. So this is where the cycle comes. So this is the first cycle we are getting. Then again process 3 is requesting the resource 2, which is held by process 2 as well as process 1. So it is dependent on process 2 as well as process 3. So there is a cycle of process 2 to process 3, then process 2, then there is also a cycle of process 1, 2, 3 to 1. So they are in, like if you identify with respect to mutual exclusion. Okay, so mutual exclusion is something where all systems are independent and each resources are like different. So this is like a shareable. Okay, and there are the resources can be either shareable and non-shareable. So we'll come back to later that point. But here it is mutual exclusive system. Yes. Then hold and wait exist. Yes, there exists a hold and wait where process 2 is holding a resource 1 and it is waiting for resource 3, which is held by process 3. Then in the meantime process 3 is again waiting for process 2 to release the resource which is held by, that is resource 2. So now there is a hold and wait for process 2, 3 and process 1 and 3. Yes, there exists hold and wait. And no preemption. Obviously we are not preempting any of the processes. If you preempt, means if I preempt any of the process like process 3, so I can uh, solve the deadlock where if you take the process 3, resource 3 is free and it is not even requesting the resource 2. So suddenly process 2 will take the resource 3 and it will execute and it may release. So there is no preemption is occurring here. Okay, so no preemption. Yes, there is no preemption and there is a circular wait. Okay, so that this is the point, like process 2 to 3 and process 2. So there is circular wait also exist. So all the four conditions are now simultaneously occurring in this system for this given diagram. So if there is this scenario, so we can tell yes, the dock is occurred in this system. So we have to solve. We have to solve by using some techniques which we will see. So hence, if there is exist any of these kind of scenarios, we have to check with all the four conditions and tell, okay, so it's now satisfied all the conditions. Now the deadlock is occurred in the system. Yes, 100% there is a deadlock. Now going back with the next example, we'll see again there is a resource allocation graph, uh, but there is a cycle, but here there is no deadlock. So we'll come back this point. We'll see how deadlock is there or not. So uh, if if you see the previous example, if there is a cycle, means hold and wait and circular wait, both are cycles. So there is a cycle occurred in the system, hence we are telling it is a deadlock. But is it a true every time? It might not be. So that is the case here. So again we will take out all the four processes and we'll just write what exactly that system is given. So process 1, it holds the resource 2 and resource 2, sorry, resource 2 is allocated and it is requesting the resource 1 held by whom? Okay, held by process 2. Okay, then so everywhere, so I have to make held. Okay, then process 2, it holds the resource 1 but it is not requesting anything. Yes, then process 3, it holds resource 1, then it is requesting a resource R2 which is held by process 4 as well as process 1. Okay, so might be we will think about process 1, and I think this has to be changed. Okay, so process 2. Wait a second, it should not be like this. So it should be like this with process 4. Okay, so uh, if you see that process 1 is requesting resource 1 which is held by process 2, so just I have drawn the diagram. So process 2 is not requesting anything. Then process 3, it is actually allocated a resource 1 but it is requesting resource 2 held by process 1. So this is the diagram here. Then it is also resource 2 is also allocated for process 4, so hence it is also requesting for that process 4. Then process 1 is also requesting resource 1 which is held by whom? Process 3. So if you see there is a loop here like process 1 to 3 and process 3 to 1. So there is a cycle exist. So if there is a cycle, again there might be a circular wait, but we'll come back and we will see now how the mutual exclusion. Yes, mutual exclusion is like all the processes are mutually exclusive process and they have been allocated their non-shareable, sorry, shareable resources. Okay, uh, there is a hold and wait scenario. So hold and wait, like process 1 is holding resource 2 but it is waiting for resource 1 which is held by process 3 and process 2. So this is a very important thing where process 2 is holding a resource R1 but it is not requesting anything. So what will happen is process 2, if it executes, then this resource is released. Resource 1 is released, R1, that one instance is released, which process 1 might take. It is not necessary that it has to be a process 3 always. A process 2 might also release the resource 1 so that it can take that resource. Hence, the cycle might break. So it might be a scenario with respect to process 3 where process 3 is requesting for resource 2 and which is held by process 1 as well as process 4, but process 4 is not requesting anything. So whenever process 4 completes its execution, it will release the resource R2. Hence process 3 might take that resource R2 and it might execute, and it may return or it may release a resource 1 held by process 3. Then process 1 might execute, even though it looks like a cycle exists, but a deadlock is not. Hence, if you see the deadlock, it is not uh, necessary that whenever a cycle exists, a deadlock might exist. But that's why that example where there is a cycle but no deadlock. Whenever there is a cycle, there has to be a deadlock, but it is not necessary. Like we have to check and see whether they are dependent. The processes are 100% dependent on that. Then only the deadlock might exist. That's why we should remember if a graph contains no cycle, there has to be a no deadlock. 100%. There is no deadlock because there is no cycle. They are not dependent. Means they are not holding and waiting for the process, which is again dependent on that same process. Okay. Uh, if there is a graph which contains a cycle, there exist two scenarios where if only one instance per resource type, then deadlock. Means if you see this example, if there is only a one instance available, means R1 is only available, then P2 is not given a chance, or maybe P3 is not given a chance. So 100% there is a deadlock because until and unless it gets that resource, so it will wait for infinite time. Okay, so if there is only one instance, 100% there is a deadlock. If there are several instances per resource type, possibility of a deadlock. That's why that previous example, there are two resources, there might be a possibility that process 2 process 2 might release a resource so that it can be used by process 1. So hence there might not be a deadlock in this case even though it contains cycle. So uh, we have to check with all the four conditions and how deadlock will occur or not. So it is like somewhat analyzing there might be a deadlock or not. So we have to take care of this request. If the process 2 is requesting some other process, the scenario might would have been changed.